Coming up, we take a look at SQL Server 2017, which brings the mission-critical performance, security, and availability of SQL Server to Linux and containers. We're going to show you how the SQL Server that you know now runs on Linux and the new platform abstraction layer, and how well that performs. We'll also show you Active Directory authentication on Linux, and the high availability options, as well as failover between Windows and Linux platforms. And stay tuned too, as we'll show you support for graph analysis to identify new relationships in your data and more. Joined today by Travis Wright from the SQL engineering team. Welcome.
Hey, thanks for having me back.
So back on the mechanics last November, you launched SQL Server 2017 in preview. Now that the product's complete, what's new?
Yeah, so the main focus for SQL Server 2017 is to bring SQL Server to the Linux platform and containers. At the same time, we continue our cloud-first development model. So all the new features we've been adding to Azure SQL Database recently, those will now show up in SQL Server, things like SQL Graph. And since the preview in November, we've been adding a bunch of enterprise capabilities to SQL Server on Linux. That includes high availability, security features including Active Directory authentication, and we've achieved performance parity between SQL Server on Windows and Linux.
So I bet if you're watching this, you're probably wondering, did you have to actually rewrite SQL Server in order to bring it to the Linux platform?
Yeah, fortunately, no. We've been actually trying to work on optimizing SQL Server and more directly talk to the hardware for a while now anyway. So if you think back to prior to 2005, SQL Server, like other apps, leveraged Windows for hardware resource management. Then in SQL Server 2005, because we wanted to have better control over the hardware resources to improve performance and scalability, we brought the hardware resource management into SQL Server user mode process so that we could better control that. And that's what we call the SQL OS layer. And that's responsible for processor scheduling, memory management, network and disk I/O. And at that point, SQL Server really no longer had a dependency on Windows for hardware resource management. A few years ago, Microsoft Research identified about 50 application binary interfaces, or ABIs, that all of the Windows API surface area sits on top of. And it just narrows down to those 50 ABIs. So to bring SQL Server to Linux, we took a small number of Windows binaries that SQL Server actually interacts with. And we then brought that together with the SQL OS layer and packaged that together and brought it to Linux. And that's what we call the SQL Platform Abstraction layer. And then as part of the SQL Platform Abstraction layer, we intercept those ABIs that are in Windows, and we remap them onto the ABIs of the host operating system we're running on. And that's what we call a host extension. And today we have one for Linux and we have one for Windows. And the result is that regardless of which operating system SQL Server is actually running on, it thinks that it's running on top of Windows.
Right, and another benefit here is that you didn't have to rewrite SQL and there's not really any emulation running.
Yeah, exactly. It's the same code that we've always had, same high quality. And the other benefit is that as we introduce new features or we fix bugs, that'll show up on Windows and Linux at the same time. An example of that is SQL Graph, which we'll see later. That was actually developed by developers running SQL Server on Windows, but it just works on SQL Server on Linux. And then we optimize the code paths through the SQL PAL so that we get the same great performance we've always had with SQL Server, whether it's running on Windows or Linux.
So can we see then how the two platforms compare in performance?
Yeah, definitely. Let's take a look. So here I've got a couple of virtual machines running in Azure. One is running Red Hat Enterprise Linux. The other one is Windows. They're DS11 V2 VMs with 2 cores and 14 gigs of memory. Over here in my terminal window, I have a benchmarking application that we use to put some load on the server and measure the performance. So let's kick this off in both of these windows here. The one on the left is targeted this VM running Windows, and the other is the VM running RHEL. So you can see that the connections start spinning up here, and once all the connections are created, then it'll start measuring some transaction performance of both doing some inserts as well as some selects. And here you can see the milliseconds of how long it takes to do a particular transaction and the rate of transactions per second. You can see that across SQL Server on Windows and Linux here, the performance is approximately the same, right? So let's just give it a couple more seconds here. And now we can see that the result here is 8,914 transactions within that time frame, and over here with SQL Server on RHEL, it's 9,229. So within a couple percentage points. And you can run this test all day long. It's kind of fun actually to do a comparison between the two. And sometimes SQL Server on Windows will win, sometimes SQL Server on Linux will win, but the performance is always within a couple percentage points.
So pretty fair race then. This is a basic performance demo. Any other benchmarks that we have?
Yeah, of course. We want to do more sophisticated and official benchmarking testing. And so to do that, we run TPC benchmarks. That's sort of the industry standard. So in fact, we actually just posted recently a new world record for the 1 terabyte data warehousing benchmark with SQL Server running on Red Hat Enterprise Linux. And as you can see here, we actually beat the previous world record holder, which was SQL Server 2016 on Windows. And so what you can kind of infer from this is that SQL Server 2017 is actually faster than SQL Server 2016. And that's due to some improvements that we've made in the query processing engine.
So not a platform-to-platform thing, more of a year of progress on SQL Server.
Right. So the demo shows you how SQL Server on Windows is comparable to SQL Server on Linux in terms of performance. And then this benchmark shows you how SQL Server 2017 is actually faster than SQL Server 2016.
So the SQL platform abstraction layer really gets you a long way in terms of where you need it to be, but I know there are some things that we like to take for granted or sometimes take for granted in Windows, such as Active Directory-based authentication or clustering services, and those aren't the same in Linux. So how do you solve for those?
Yeah, for Active Directory authentication, once your SQL Server is on a Linux host that's domain joined, you can connect to it just like you can on any other SQL Server. So let's take a look at that. Here I am on a Windows PC. I've got SQL Server Management Studio open. And I will just connect to a database engine here. And here we'll just connect to RHEL1, which is a RHEL-based instance of SQL Server. And you can see here that I'm connecting with my Active Directory authentication credentials. I just hit connect, and I connect to it just like I would any other SQL Server that's on SQL Server on Windows, right?
So how about clustering?
For clustering, we leverage Pacemaker, which is a cluster manager in Linux world. And that's basically the same as Windows Server Cluster Services. So let's take a look at what that looks like here in SQL Server Management Studio. We have support for always-on availability groups as well as normal failover clustering with shared disk. So here we'll open up the always-on availability group dashboard, and we can see that we have an always-on availability group for this server, and there's 3 RHEL-based nodes in this always-on availability group. And then over here, I have a simple application that just connects to the cluster name for that cluster and just outputs the name of the cluster node that it's currently connected to. So now to simulate SQL Server going down for some reason, let's just go over here and stop the SQL Server service. And we'll give it a few seconds here, and that will eventually kill off the connections that are coming in here. And now we can see that it's trying to reconnect. Okay, so now we can see that the connections are starting to come back online. And you can see this is now connected to RHEL2, which is now taken over as the primary node within that availability group.
So out of personal curiosity, and this probably doesn't work, but can I have an always-on availability group between Windows and Linux hosts?
Yeah, actually you can. We've had that question quite a few times. We don't recommend it for an HA scenario because there's no cluster manager that spans Windows and Linux yet. But it's great for a couple different scenarios. One is where you have a need for like an OS level redundancy. So imagine a scenario where you have an always-on availability group that spans Windows and Linux, and there's some zero-day vulnerability you have to patch on Windows. And so you would maybe fail over your entire workload to your Linux side and patch your Windows and then bring it back. Another scenario is migration, where you have a workload running on SQL Server on Windows today in an always-on availability group. You add a few Linux nodes to that cluster, replicate the databases over. All of this happens online, right? Your applications continue to work. And then when you're ready, you just fail over. And that's how you can migrate with basically just a few seconds of downtime.
And that would work if I'm going to Linux or back to Windows?
Yeah, either way.
You're just seeing a lot of great capabilities coming to Linux, but are there any new capabilities that are coming to both Windows and Linux?
Yeah, there's really 2 main things. The first is graph support, which we've added, and then also support for Python for our machine learning services. Today, people need to typically have a dedicated database for running a graph database, something like Neo4j. What we've done with SQL Graph is we've actually brought graph database capabilities into SQL Server in SQL Server 2017. And that helps you kind of get those inferences out of the many-to-many relationships that you have in a graph type of data model. So I'm going to jump back to my Mac here and show you what that looks like.
Okay.
So here I'm going to fire up a container running on my MacBook. And here I've got Visual Studio Code open, and I'm going to connect to it using the new SQL Server extension. We can see that we're now connected to the master database in my container. So let's just create a quick database here that we're going to store some graph data in. To create a node table in SQL Server is just like creating any other table in SQL Server, except that we have this as node syntax here. So I've created some tables here to store some information about my factory. Now I want to create some edge tables. And you can see that creating edge tables is also the same as creating any other type of table in SQL Server, except we have this as edge syntax here. So now let's insert some data into these tables. And you'll notice just by looking at these queries that it looks just like inserting data into any other SQL Server table, except that with these edge tables, we're inserting the node ID for each end of the edge into the table. Let's go ahead
We're
and
just
insert all
using
that data.
T-SQL here?
Yeah, just T-SQL, right? And the syntax is essentially the same except for a few new keywords that we've added to the language. Now that we've got some data in there, we can actually start to write some queries which go and look at this graph data. And you can see here that the graph query syntax makes it much easier to write a query as opposed to having to write a big long set of join statements. And you don't have to worry about what the difference is between an inner and an outer join.
Right.
The syntax here is really just much easier to use. So one of the benefits of this is that you get your graph data right next to your traditional relational data, and you can join between the two different data sets, as opposed to having your graph data off in some separate database and trying to figure out how to bring that together with your relational DB. The other advantage is that you get all the power of SQL Server with your graph data. So if you want to have some of the advanced features for security that SQL Server has, you can do that. Or as we'll see here, I can create a clustered column store index on the machine table here, and that improves the performance of your queries by 30 to 100 times by using our new column store feature. That is an in-memory technology that also compresses the data on your disk to save you a lot of space.
That's a huge performance boost, but you also mentioned Python support is also available now on SQL Server 2017 for building intelligent data models.
Right, so in SQL Server 2016, we introduced support for R. And now in SQL Server 2017, we've added Python to our machine learning services. And those are the two main languages that data scientists use to analyze data. And the interesting thing that we've done here is we've actually put R and Python in database. So you can actually execute these R and Python scripts where the data is at instead of having to pull the data out and process it on a different server. So in SQL Server 2017, we also added the ability to offload these scripts to GPUs for even faster performance. And that's available with SQL Server on Windows today, and we'll be adding it to SQL Server on Linux in the future.
So a really great fast tour of SQL Server 2017, including the new Linux capabilities. But if you're watching at home, where can folks go to learn more?
Yeah, there's so much more we didn't even have a chance to talk about today, like running SQL Server on Windows or Linux VMs in Azure. So go check out more at the link below.
So thanks, Travis. And of course, keep watching Microsoft Mechanics for the latest tech updates across Microsoft. And we'll see you next time.